Okay, hi again, grade 8s. So what I'm going to do now is I'm going to go through some of the things your graph has to have on. And we mark you down on this, so it's very important that you have everything on the graph that needs to be on there. So it's when you're representing your data, at the bottom of page 23, you will see there's a whole list of things that you need to include. I want you to highlight, add extra notes as I'm talking so it can help you later on. Okay. If you look at the two pictures I've got over here, I've got one picture that's showing plotting a line graph, and it shows that you need to add a title, you need to have labels, you need to have a scale, and you need to have a line of best fit. That's an example of a simple graph that you guys are going to be expected to do in the exam. Then on the other side, we have got concentration in moles per decimeter and time. And we're looking at gradient. So gradient is the rate of change between two variables. How do they change? And at what rate are they changing? So you don't need to know that now. We learn that next year. But I just wanted to put that in there just to show you what we do later on when we try and look at the rate of change between the y and the x axis. All right, so we are going to just jump right in. The first thing that your graph needs to have is axes. So graphs have two axes. These axes are described with labels and units. Units are very important, grade 8s. If you don't put the unit there, I'm going to minus mark from you. And it's always in brackets. The labels consist of words and phrases. They do not consist of variable letters. On the horizontal axis, you have the independent variable. Please highlight that. On the x-axis is always your independent variable. Please remember that. And then on the y, you are going to have your dependent variable. Now this relates to the title, and I'm going to get into that now a little bit later. But for now, that is all you need to know. The first thing you're going to do before you do anything else is identify what must my independent variable, what must my dependent variable, and actually label your axes. Right, so scale is where a lot of kids struggle because they look at the table and then they think, oh, I must put exactly what's on the table on the scale. Doesn't work like that, guys. We need equal increments. So, for example, if your data is going, look at that picture that we've got here. If your data, your independent variable, is going from 10 to 60, so the minimum amount, let's throw it out there. The minimum amount is, let's imagine that the x-axis has got distance or time. Let's put a time. Time in seconds. There we go. And the minimum that you have for all your data points is 5 seconds, and the maximum you have is 65 seconds, which is actually 1 minute 5 seconds. Then on the y-axis, I have, let's say, meters, for example. That's super fast, by the way. But let's play around with this. Then my lowest amount is going to be, I'm going to say 2 meters, and my highest will be 65. I'm just throwing these things out here now. What we want to do now is make sure that when you put your scale on your graph, it is an equal increment. So please look at the box that we put there. We've said the scale for here, it shows that for one interval, in other words, one little box means 10 units. And we look at this when you are drawing your graph. Does your scale match up? Does it match up? Like you want to fill up your entire axes at least 75%. So are you consistent? Is it the same always? You can't have one interval being 10 units and then all of a sudden decide one interval is going to be 20 units. Then you're going to lose marks, and also your data is not going to be accurate. So this is very important. It takes practice, but you'll get there. Okay. So the scale must start at 0 for each axis. The values go up by the same amount each time. the scale on the x-axis can be different to the scale on the y. It doesn't have to be the same, guys, really. Add lines to show scale increments. Values are added on the graph with dots and crosses to indicate where the variables cross. Okay, we are going to do all of this. These are just the baby steps. Just chill. As I said before, we are going to look at the title and the heading. And the title and heading represents what's on your axes. So guys, and we are very, very strict with this, it needs to be the dependent variable versus independent variable. So for example, let's look at this picture that we've put up over here. We've got the independent variable is the day number, the number of days. The y-axis is the amount of rain in centimeters. So therefore, my title is going to be something like graph showing the amount of rain versus the number of days. Can you see? I always have the dependent variable versus the independent variable. That is standard. It doesn't matter what your graph is going to do. It has to be like that. Guys, if it's not like that, we minus a mark. Okay. Let's look at this baby. The line of best fit. It's one of my favorites. The line of best fit is going to show you the trend of your data. In other words, what is the pattern? What is your data doing? Is it increasing? Is it decreasing? Is it plateauing? What is happening there? What is the general trend? Typically speaking, we like the line of best fit to go through the origin. However, depending on the data, it doesn't necessarily have to go to the origin. What is the origin? That is where the x and the y axes intersects. You don't have to you don't have to do the line of best fit through there. Okay. Sorry, the line of best fit does not have to be a straight line. Sometimes it can be a curved line, especially with an inverse correlation. If it is a direct correlation or a direct proportion, like the first graph that we're showing there, where we've got braking distance in meters and the mass of the car, then it's going to go through the origin, which is the intersection between the y and the x. If it is an inverse relationship in the second diagram or the second picture I've got there, I've got Boyle's law. You know what that is? That is volume versus pressure. That's chemistry. You don't need to know that. That's later on. But this is a nice graph to show that the pressure in mass of a gas is inversely proportional to its volume at standard temperature. Temperature, room temperature. So we do that later on in chemistry, not now. But can you see there's no line going through the origin, but it's showing the curve. It's showing the actual trend. This is very important. You need to highlight this. We take marks off for line of best fit as well. Okay. The next two things we're going to do is key and actual size of your graph. So just quickly, we're going to talk about key, like I spoke to before. You can have two sets of data on one graph. So let's look at this bar graph. So even though we're not going to expect you to draw a line, a bar graph, you need to know this is a nice picture to represent the key. Can you see on the side, also known as a legend? It's also known as a legend. We've got boys and girls on one graph, and we're looking at the number of people and the food type. And between boys and girls, what do they enjoy more? And it's pretty obvious that boys enjoy pizza more than girls, girls enjoy chocolate more than boys, and girls enjoy ice cream more than boys. So this is a bar graph representing two sets of data, and that little block on the side is the key. Then in the Excel picture of the Excel line graph, multiple line graph, can you see there's 3 years represented on there, and the legend at the bottom shows year 2016, year 2017, and year 2018. An example of a graph. An example of a key that you would be expected to to draw or input in your graph, whenever we gave you a project to do. Okay. All right, so just quickly, I just want to go through the fact that your graph needs to have it needs to cover at least 75% of space. So you can't have all your data in the corner in the first 20% of your graph. Then we won't be able to see a trend. We won't be able to see a pattern. So space out your scale. Space out your labels. Make sure that your entire y-axis is labeled and your entire x-axis is labeled, not just half of it. So guys, I don't want to see like this, where the graph ends here for time and it ends here for speed. Because then what's going to happen is all the information is going to be in this space over here, and nothing is going to be here. That's why I mean 75% of the graph space must be taken up. Can you see, I've just added an example of 2 headings. You can write these down to help you. The first one shows a line graph showing speed versus time. Can you see speed is on the y-axis and time is on the x? And here we've got the line graph showing distance versus time. So the heading that they put up is incorrect. It should be distance versus time, because distance is on the y-axis and time is on the x. Finally, grade 8s, what we're going to do now is we're going to go through some of the rules. So the rules are on page 24. There's also a picture at the top that shows a lovely graph for you and how you would add everything in, and so that you don't forget what needs to be included in your graph. So these are the commandments, the rules that myself and Mr. Ginsberg want you to live by. The first one is it needs to be in pencil with a ruler. You do not draw dot to dot, but you need to draw your graph in a scientific manner. In other words, no sketching. This isn't art. I want it with a ruler and with pencil. If you draw it with pen, I'm minusing a mark. You need to use 75% of your graph paper. You need to label your axes, and you need to always give units in brackets, always. So if it's distance, it's in meters. If it's time, it's in seconds or minutes or even hours. Then you will not draw bar graphs. I don't want to see a bar graph in science, ever. I'm going to put a big red line through it if I see a bar graph. And the last one, which is number 6, and I think my camera is covering it here, it's you shall not play dot to dot with data points. You do not draw dot to dot. You don't draw from here, for example. I'm going to use a red highlighter, maybe. Let's see if this works. You don't draw like this. This type of data, I would use a ruler and I would draw the line of best fit through it to show the general trend. I wouldn't draw from dot to dot. Okay, please do not do that. Right, so grade 8, that is it for this video. The next video I'm going to do, I think it's called activity 11, which is on page 25. So once you're done with this and you're happy with this, please watch the third video.